All right, so let's get started. So this is where I think this is where we left off yesterday. Uh, just a reminder that with glaciers, so you saw what some of the questions are going to ask. So some of them get into a little bit more detail than others. Some kind of combine your more like thinking and reasoning skills along with the earth science knowledge. We'll go through them, see where you guys struggled with that. But for the notes for glaciers from yesterday, this is what you needed to have on there. Keeping in mind that the Regents didn't ever ask you what was a striation, what was a moraine, what was a kettle lake. You just need to associate those terms with glaciers. So when you hear these vocab words, I want bells and whistles going off in your head saying, oh yeah, glaciers make those. They're very big on the U-shaped valley. So that is one reason I did have us draw the U-shaped valley. There is always a question about either a U-shape or a V-shaped valley on the Regents. And you just need to know what kind of erosion makes a U or a V-shaped valley. We haven't done V-shaped valleys yet. So yeah, it is a river. Yeah. Did you have a question or no?
Kind of. You're saying how we wouldn't use the other thing in our life.
Yeah, the earthquake stuff.
Yeah.
This stuff. Why you're saying you don't care either?
How would
Yeah, so maybe so Luke asked, well, why do we care about glaciers? And you might not. I'm not gonna lie, this one you might not come across. Erosion in general, you will come across. Maybe not glaciers. This one is important-ish for New York State because glaciers are what made our state look the way it does. It's why we have the Great Lakes. It's why we have the Finger Lakes. It's why we have Holiday Valley and Kissing. It's like why our area looks the way it does compared to other places where they didn't have glaciers and they don't have a lot of that stuff. In fact, we're going to talk about one of the questions in the homework. One of the answers talked about gravel. We have a lot of gravel pits around here. The gravel pits, the Granats gravel pits around here. Guys, what is gravel? It's little sediments. But it's not only little sediments, it's a mixture. There's some sand, there's some silt, there's some clay in there. Glaciers brought the gravel here to New York State. And the fact that since there's like a hunk or a pile of sediments over at that gravel pit, how did that gravel get exactly where it is? What had to happen to get it there? Erosion happened. It picked up the sediment somewhere else, but there is gravel in what town is that? Chaffee over there? I don't even know. Wherever the gravel pits are, they're all over around here. What made the gravel get put there? Glaciers. What did the glacier do to leave it there? It deposited. What did the glacier do to deposit it there, though?
Melted.
It melted. It just so happened that the glaciers melted basically in our school district to give us those gravel pits. Now, you might not have anything to do with the gravel pits like directly. Maybe you do. Maybe you know somebody who works there. Maybe you know somebody who owns it. But those people are making a ton of money on stuff that glaciers did for them. Like I said, you might not know anybody, but Granats then pay school taxes. The fact that they're making money and have a business in your school district is giving our school more money. So glaciers, so why do we care? You might not realize you care, but glaciers are giving your school district money even today because they dropped off the gravel. Granats is making money out of it, and then Granats is paying for some school taxes. So glaciers do have more effect on New York State than the earthquakes did. So that's my reasoning. You still might not care, but there at least is a little bit of a connection. So again, with this stuff, where I was going, you don't have to know any of this, like what is a moraine, what is a striation off the top of your head. You just need to know that they're made from glaciers. And then you do usually ask about what we just talked about. Glaciers created most of New York State's landscape. Now, I'm not sure, in this class, did we get into the Finger Lakes and the Great Lakes? Did you take notes? We just did the Finger Lakes. Okay. Please excuse my gravelly voice. Had no voice by the end of yesterday. All right, let me find that slide. I think I went. So we talked about the Finger Lakes yesterday already. So remember, the Finger Lakes are here in the middle of New York State. Now, one thing that they might ask you about is how do the Finger Lakes, like, can you tell which way the glaciers were moving based on the direction the Finger Lakes are? So in other words, did the glaciers move north and south or east and west? North and south. I think that's pretty obvious to see that because the lakes are going north to south, the glacier was moving from the north to the south. And then when it melted, it went back the other way from the south to the north. There's no way the scratches in those Finger Lakes would have gotten formed this east to west. They're just in the wrong direction. So we took some notes on Finger Lakes yesterday. I think in the end, I asked you to take those 2 bullets for Finger Lakes. Do I need to wait while a few of you type those in? Yeah, it looks like a few of you are writing those in. So I'll give you some time to write those 2 bullets in for Finger Lakes. In fact, I'll add them in too. All right, so then we're going to move on to the Great Lakes. So the Great Lakes include Lake Erie, Lake Ontario. Then those are the 2 we care about because those are the 2 in New York State. But there's also Lake Michigan, Superior, and Huron over a little bit more west of us. Now the next slide, don't write the next slide. There's too much here. But these glaciers, these lakes are kind of new. They're about 10,000 years old. And I know that doesn't sound new to you, but keep in mind the Earth is 4.6 billion years old. Don't write this. This is too much. So 10,000 years is a baby compared to the age of the Earth. So these lakes are pretty new. They formed at the end of just the last ice age. Now, in this case, the glaciers literally they carved out, they made the holes the lakes are sitting in. And then when the glaciers melted, they deposited the water. That water then filled up the lakes. And this is kind of just a fun fact that the Great Lakes contain 20% of the fresh water for the whole world. 20% of the fresh water for the entire world. If I take a picture, or if you look at the globe, my thumb is literally covering more than just the lakes on this entire globe. 20% of all the fresh water is under my thumb on this globe. That's a lot. It's one of the reasons, do you guys ever think about using water? Okay, so some of you do because you guys have well water. Okay, so it doesn't, okay. So those of you who know about running out of water, or you said. Okay, so some of you guys do have well water and you know about running out of water. Those of us who have city water, we don't ever think about you running out of water. It does barely cost anything. My water bill is only like $50 for 3 months. My electric bill is $90 every month. And then I also have a gas bill too. So water costs next to nothing compared to all the other utilities. And that's because we have so much of it right here. But places out west, their water bill is just as expensive as their gas bill. And the states and the cities put fines on them for using too much water. So if they use too much water, they have to pay a fine on top of that. And that's because we're just so used to having Lake Erie right here next to us. So what do I need you to write about the Great Lakes? Add this into that. This is the only bullet we need. Basically, the ice carves out the lakes, and then they were filled in with the melt water. So that we should have gotten all this in yesterday. So sorry we forgot some of that. Ran out of time. Now let's talk about the questions once you're done writing this. So I gave you 14 questions that the Regents will ask you about glaciers. Like I said, you don't need to know a super huge amount about glaciers, but this is what they're going to expect from you. And like I was saying, some of the questions you kind of have to use your thinking and reasoning skills. So for this first question, they said, which statement about glaciers has a positive effect on the economy of New York State? Going through this, the glaciers did do some of this. For example, glaciers did remove some fertile soil from some places, but would that have a positive effect? No, removing fertile soil would have a negative effect. Glaciers have nothing to do with oil and natural gas. If they did, I would have brought that up yesterday. So that one's not it. And this one said the water reservoirs were reduced. First of all, they were not reduced. And even if they were, that would have been a negative effect. So just like we were just talking about, glaciers brought in sand and gravel, and now companies can sell that. All right, so I'm going to go through these. If you have any questions, let me know. So number 2, the answer is 2. So those boulders, like we were talking about, those are called erratics. They were brought by glaciers. And remember, anything that is transported by a glacier is going to be unsorted. Do you guys remember what it means to be unsorted? Yeah, it means it's not sorted. If it was sorted, all the sizes would be the same. Unsorted means it's all mixed up sizes and shapes. For number 4, gravity is what's going to cause the glacier to move down the hill. Number 5, how fast the glacier moves down the hill, just like how fast you ski down a hill, depends on the slope of the hill. So if the slope is greater, then the speed will be greater. Remember that glaciers create U-shaped valleys. They will always, always ask about that. Everything okay over there? Over a period of years, the glacier gains more snow mass than it loses. If it's gaining more snow mass, is it going to get bigger or smaller? Yeah, it's going to get bigger. And if it's getting bigger, will it retreat or advance? I don't think we talked about those words yesterday, did we? Do you know what the words retreat and advance mean? Just like you've learned probably in social studies or something like that with armies, if they retreat, that means they're running away, so going back where they came from, and advancing means they're winning. So they use those words to describe glaciers, just like because glaciers do just as much damage or change as a war would. So if a glacier's getting bigger, is it going to retreat or advance? Yeah, it's going to advance. It's going to go forward. This is a classic question, which is almost the same as one from before. Which pile of sediments will the glacier leave behind? Why 4? It's called unsorted, all mixed up. All right, just like the Great Lake, just like the Finger Lakes, the directions of the striations, which if you read on here, the arrows on the map show the location and orientation of striations.
Hi.
Hey, what
Want me
does
to
the
take a
word?
chair?
If you go out the hall towards the doors, there's a chair out there. Wait, a table, a desk, and a chair
Okay.
right by the door.
Wait.
Bottom of that blue bin right there. Blue bin closest to the class, bottom. There you go. And you can grab a scrap paper if you need it. The directions here told you that the arrows are striations. Guys, what's another word for striations? Scratches. So according to these scratches, which way was the glacier going? So you can see all the scratches go that way. They're going north to south. Nothing about, so sorry, let me read these. They're going from the northeast and I'm sorry, let me read this. Was towards they were going towards the southeast and southwest. Always important to read the question really carefully. I'm sorry, I should have told you to skip question 10. We have not learned that yet. Which feature would be determining the thickness of the ice sheet? I didn't talk about this yesterday. This one might require you to think and reason again. We want to talk about if an ice sheet's really thick, what else will you know about that ice sheet? It's thick. So it's doing a lot of things. It's going to also be really heavy. So the thicker the ice sheet, the more grooved the bedrock will be. Those grooves happen when that glacier scratches all the way down. So if it's a really heavy glacier, those grooves are going to be bigger. Again, how did the striations form? That's answer 2. Rocks at the bottom of the glacier were dragged over the bedrock. And they tell you a moraine is recognized as glacial deposits. What do we know about things that glaciers deposit? You told me here that they were unsorted. So we want ones of many different sizes, so not uniform. Now, layered or not layered? Not layered. Layering is a type of organization. So like this one was many different sizes, but they were organized. That's not unsorted. Unsorted is when it's just a pile of mixed up everything. And finally, because of glaciation, New York soils are best described as, let me teach you this one. Didn't talk about it yesterday. Did glaciers, let me actually talk about a couple words. The word residual, any idea what residual means? What does it sound like, residual? Nothing? It is. It's exactly what it is. It's something that stays behind. Let me describe this to you. Do you guys see the word residue in that word at all? Ever eat a big old bowl of Kraft macaroni and cheese? Even if you haven't, I'm sure you can picture it. You eat all the noodles. How's the bowl look when you're done? Is it clean? Clean as a whistle if you ate all the noodles from Kraft macaroni and cheese? What does it look like? It's yellowy, orangey yellow, because some of that cheese residue gets left behind. Residue is stuff that is left behind. Residual is stuff that is left behind, never moved. It didn't go anywhere. Just like that cheese didn't go in your belly, residual soil hasn't moved. So in New York State, do we have a lot of soil that's never been moved? No, our soil was all brought here by glaciers. Speaking of, New York State is not unchanged by glaciers. Our soil, do we have a lot of gemstones in our soil? Yeah, guys, find a diamond in your backyard ever? Any rubies? No. Our soil is thin and rocky because of glaciers. All right, that was a bunch. Let's check out something new. Actually, I think I want to go this way. I'll show you guys the video. I'm going to tell you this video is old. And it was before, this was, I think they said sometimes in the 90s. So let me just tell you, back in the 90s, we didn't carry around cameras. We didn't have phones in our back pocket just to whip out and record something. This guy happened to have a video recording camera, probably one of those big ones, and caught this on camera, and I think it's really cool. Take a look at this.
Portland, Oregon, February 1996. A mountain begins to move, and for a contractor and his son, there's only one option: get out of the way fast. Oh my God! They had just gone head-to-head with one of nature's most powerful and destructive forces, a landslide. The surface of our planet is constantly reshaping itself, and landslides are a major reason. They strike wherever the soil is loosened by rain or tugged by gravity. It can be a rockfall or a raging river of mud. But wherever the ground fails, it can result in massive destruction. On average, landslides kill more than 8,000 people every year around the world. They can crash down without warning and travel for several miles. In the U.S., landslides occur in all 50 states, but some places are more dangerous than others. Landslides usually follow other natural disasters like volcanic eruptions, earthquakes, wildfires, storms, and floods. Steep slopes are obvious places for landslides, as are areas that have been hit by landslides before. But they also frequently occur where people have radically altered the landscape. Hills stripped of vegetation, slopes modified for roads and buildings. And as our cities and towns expand further, landslides become more frequent and more destructive. In 1998, disaster struck the Southern California suburb of Laguna Niguel. Few realized that the man-made hill beneath them could fail. The ground, eroded by heavy rains, began to give way, and the houses came crashing down. 7 were seriously damaged, and 5 of them tumbled down the cliff face. Though the ground cracked and the earth plummeted, no one was injured. The residents of Laguna Niguel were lucky. They still had their town. The following year in Venezuela, torrential rains triggered widespread landslides across a 25-mile-wide strip of coastline in the state of Vargas. Communities were buried under waves of mud and debris. It's estimated that 30,000 people were killed, around 10% of the area's population. Accurate death tolls were difficult to establish because so many people vanished under the mud or were swept out to sea. Though the catastrophe was on a massive scale, it is by no means unique. Such disasters have happened before and will happen again. As long as the earth continues to move, people will live with the threat of landslides.
Luke missed it, why we should care. But ay. Hang on, cancel. All right, I want to do another one that I have here. So just to show one more video before we go ahead and start talking about some more erosion. Here's a cool one.
Slide that will give any driver the chills. It began as a trickle, then it all came crashing down yesterday on U.S. Highway 64. Ikes, it was the second rock slide that morning, crews had to break up the car-sized rocks to clear the road. Good morning, everybody. How about that? Man, look at that.
So the road wasn't blocked off at the time, yeah.
Was
Even though
not.
there had been a previous.
Where was the camera?
No.
That's
Good
what, like,
question.
We are
took
everywhere.
that?
We are everywhere.
Great question.
I'm just going to sit here until these rocks
Look at
come
that.
down.
That is amazing.
Well, there had
Stunning.
been a couple of previous ones, so I guess they were watching.
I'm late, honey, I'm late.
Well, you know
It was
what?
a rock slide.
Oh, yeah.
Right.
They're so funny. Sorry. Watch that video too many times. Those people annoy me. So what kind of what kind of erosion was that we just witnessed? Not weather, because remember, weathering is the breaking of rocks. We just watched a bunch of rocks move. So we talked about there being 5 agents of erosion. Do you want to remind ourselves what they are? There's 3 W's, remember. What are they? Wind, waves, and running water. What are the 2 G's? Gravity and glaciers. What agents did we just watch there? That was absolutely gravity erosion. Everything that we watched was something moving downhill. So gravity erosion can happen in a whole bunch of different ways. So one thing that can happen, what do you think caused the trees to grow like this? The slope. What do you guys know about trees and plants in general? They grow towards the sun. So what that means is trees and plants will adjust themselves as they're growing so that they grow towards the light. Every week or so, I have to turn my plants over here because all the branches start aiming one way towards the light. And I don't want plants that lean one way like this. I want plants that go up straight. So I got to rotate them so that they keep shifting their direction. These trees shifted. What this is saying is, so how did they get like this? Why are they curved? But look at the trunks. Were they always facing that way, you think? This land used to be flat and the trees were growing straight up, just like they are now. But then the soil and the hill shifted. And now what was up, they had to adjust and turn to go to the new up, I guess you'll say. Same with this picture. I don't know if you can see from where you are, but these are fence posts and there's barbed wire. Do you think the farmer put the barbed wire on the hill like that? No, pretty sure it's not how it worked. My guess is there was probably a pasture with a cliff next to the pasture. They didn't want the cows going over the cliff, so they made a fence. But what happened then? Okay, so then this hill started to erode, and what used to be the edge has now fallen down the cliff. I know I've talked about my grandparents' house a lot on this chapter already. My grandparents had a very similar hill right next door to them. But instead of there being a cow pasture, there was a cemetery here. And it was a really old cemetery. Really, really old. And when I was a kid, there was a gravestone over here. And if there's a gravestone over there, what's underneath the gravestone are, well, the people. So more than likely, and there was actually multiple by the time they came through and fixed it. There were coffins sliding down this hill. So some sort of company came and dug up the coffins and the gravestones from over here and moved them back over to this side of the cemetery because, well, nobody wants that to happen. So could you build a wall or something? Actually, that you could absolutely. That costs money though, a lot of money, and you got to maintain it, so it's going to cost even more money. So it was cheaper for them to just let it happen and just move the coffins and stuff that were there. Like I was saying, they were like hundreds of years old, so I never was too young to know what was going on. Man, I wish I knew now. I don't know if you can see what this is. This is a viaduct. There's a bridge up here, and this is the drainage tiles. I don't think they laid these bricks like this. Now, do you think How fast does this type of erosion happen? Yeah, it takes time. That farmer didn't go out one day and go, oh gosh, my fence is down the hill. Okay, it was a slow and steady process. This is called creep. And if you are creeping around, what's some things that you're doing? Tiptoeing, you're trying to go unnoticed. Slowly, you're sneaking up on somebody. So creep is a type of erosion that is slow and steady. Compared to, we could have something called flow. What if debris flow? What are you hearing there? If it's flowing, how's it moving? Quickly. A landslide, a mudslide. These are all pictures. Oops, sorry. These are all pictures. That's mud underneath them, and that's the top of a roof. Same here. That is, this is actually volcanic ash mixed with water. And you can see that did some damage. How about a debris fall? What's that? Instead of sliding down a hill or flowing down a hill, it just crashes. Let's see if I have any. Oh, there we go. This is always my favorite animation here. We've got a mountain. You've got pieces of rocks falling on the mountain. And oh boy, that tiny town is in trouble. This would be a debris fall. This would be the aftermath. So it just goes crash and lands on the road there. The rocks will pile up at the bottom of a cliff and make this little slope here called a talus slope. If you see one of those, you know gravity erosion happened. And here are the important facts you need for page 8 for gravity erosion. I know. And you're going to have homework. Oh, I know. Page 12. Page 12, there are a sum total of 6 Regents questions. So without gravity, we wouldn't have any erosion, but gravity does have its own pull on sediments down a hill. As I pointed out in that video, the gravity, those are always going to be unsorted. Whatever's on the top of the hill is going to fall to the bottom, whether it's sand, silt, clay, boulders, houses. And also, like I pointed out in that video, we're going to have a bunch of angular shaped rocks, not rounded, but angular. Luke, did you have a question?
So if we had no gravity on the planet, we would all be floating around.
Yeah.
Is there any other like things that have
Less gravity than us?
like gravity just like that?
Yeah, they all do. Some of them have less because they weigh less, but yeah.